All right. Hi, peeps. I took a long shower. That's why I'm late. There are no excuses. Ah, finally hot water again from the rooftop. Solar is working. Hello, Sonic. Hello, Dutch. Hello, Killian. Hello, Jordy. How are you? Hello, Ray. Hello, Johnny. Hello, Autumn. Hello, M40K. So, you were talking about triggering stuff. Yeah, I will share. I was finishing the wiring yesterday of our project, and you were triggered by this thing here. Is it a cap? Oh yeah, it's a cap. It's not on purpose. I mean, it's on purpose, but it's not to trigger you. It's, there is no other way this would fit. I didn't densify the board any further, so people who missed the last streams, that's an M.2 board with 0.5 millimeter pin pitch, and we put what is this here? This layer doesn't show. PCI Express to serial, and here and RISC-V MCU, and this is just for testing some matrix. We could make it even more dense, but I believe it's good how it is now, because otherwise this would be very difficult to wire. I will show you. Will it ESA slot? No. It will fit in an M.2 SSD slot. So this is, hey Adam. So here we are, and yeah, look at this here, this area. Are you watching? Oh wait, the chat is not visible. Wait. I was wondering why is it so. Here we go. Huh? Chat doesn't show. Ah, okay. Server wasn't running. I don't know why, but here we go. Ok. Ah, hey Yumbo. Oh, I don't have anything to drink. So, I'm very upset. I wanted to start playing around with the PCI Express stuff. No, it's 80 millimeters. Oh, at least that's what will fit in here. Is the default one? I wanted one. I wanted one that fits in here, and this is 80 millimeters. Hey, Ian. Hey, Kaspar. So yeah, I hope we populated the right side. Otherwise, it will shine in the other direction. No, I think it is optimal. It was really hard to. Someone said it would be a nightmare. I mean, I shrank already the ground pad, and it's not many ground vias here. I could put there even more, but more of a mess. Hey, one DFJ. Yeah, it's an M.2 LED matrix. So the biggest mess was down here. And also this is out of spec. It's like it violates manufacturer 0.3 millimeter distance from the border. But I mean, we are just on one layer here, more or less, so that will be fine. Also, this design violates DRC rules. The pads will be just shaved off. Yeah, and this is a huge mess. Getting like the wake signal or the other signals, you can make it, what? Oh yeah. So it doesn't violate the rules, yeah. Yeah, that looks messy. Look at that. This is the layer of desperation. 4-layer board and then routing through the connector somehow feels wrong, but oh well. I had to do it. This was an extra, so I added the signals wake and real-time clock, just in case we want to detect that the PC is in sleep mode. And also, so pretty, what? And also, I don't know why we need the real-time clock. I just added it because it was on PCI Express available. I will show you the latest state of the schematic. Here we go. We obviously skipped a few parts, but look how beautiful it looks now. And I was able to find, hey TMK. Yeah, you can see it in 3D. Wait, here is it. Yeah, this was necessity, otherwise it wouldn't fit. Anna told us yesterday that he had also to do stuff like that. And here, perfect utilization of this extra space. So this is awkward because we will address it, like multiplex it column wise. So we have the resistors per row, and the first two resistors, I think that the center two rows are over here, so they're connected. Oh, you can see here. So the two resistors for the center rows are here, so it's connected to the MCU, through the resistors and to the row, like that. And all the LEDs are connected to it. You can see here. Boop, 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 boop. And because we squished in the resistors over here, the whole wire has to go this way and then return. Boop, 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 boop. Yeah, it's something like that. Yeah, nothing on the back, really. Just the matrix stuff. Optional parts are on the back, so we can keep it clean. Also, oh no silk screen whatsoever. Uh-oh. Okay, I forgot the silk screen here for the programming. But I hope we can program it over serial, so we don't need like to attach anything here. Hello, Graustreif. So, and this jumper, this bridged, we don't need to do anything here. This is the EEPROM chip where we can store manufacturer and device name for the serial. That will be, I will put one there so it shows as, hello TPCat. Do you use that pogo pin clamp? No, yeah, I will use some pogo pins. I think I don't have an actual clamp, but I just soldered some pogo pins, like very pointy ones, to a pin header, and I used that already to program. I think in the tiny LED matrix video I used a programming style like that as well. I guess there are like 4-pin pogo programmer whatever, but I don't have such a thing. So yeah, look at that. Yeah, we will buy them. I kept even some clearance here, so actually there are no wires that could break from the stress. I hope so. On all layers. So there is having program interface accessed from the host through yeah, so pol przewodnikowy it is accessible actually, but it's a little bit hard. So usually on PCI Express we have GPIOs, M.2 not on this one. So we have a serial connection between like the PCI Express to serial here, and we are using like on the ESP boards, we're using the status signals of serial to perform a boot sequence. So we can trigger like boot, reset, and so on with the serial signals. So actually, I hope we will be able to use a web programmer to program the MCU here, and then after it's programmed and booted up, we can drive the matrix with, I think it's megabit at least. It supports, I think, 2 modes. Yeah, that should work. I guess so. Wait. Pol przewodnikowy is a semiconductor in Polish? Really? I wouldn't know. I'm lacking the skills. I have currently the possibility to add voice tracks or audio tracks to my videos for other languages, and I'm playing with the thoughts to add the German track, which is already hard because all the electronics terms and so on I only like know in English, so I need like to get the translation for that and read it. Polish will be way more difficult, I guess. So yeah, I'm very upset. I tell you why in a second. Here. Yes. Polish. Oh, really? Yeah. It will happen. Okay, so. Wait. I don't want to spoil. Oh, now I spoiled my shipping number. Please don't exploit it. Okay, so here WCH dox yourself mało, yeah. Okay. 27th February. Hey Dutch. So 27th February, it was given from WCH to like the parts for the PCI, the chips and the PCI Express stuff and the dev ports. That was how long ago? a week ago. Yeah, almost a week ago. And then it arrived on Friday. It arrived in Leipzig, and then clearance event. I was called on Sunday to give specifics. There are specifics about the value and the components, everything that it is on the label. They called me and I had to type that online on Sunday so I get the clearance. And then they called me on Monday again, said, oh yeah, that's not specific enough. We need to know if the PCBs are one layer or more layers. I don't even know. I mean, there are certainly 4 layers or something, but or at least 2 layers. But they didn't ship it because they were missing the information if it's 1 or more layers. What? I hate DHL. It's like if I use FedEx or UPS, it's like they don't care. They ship it, they charge me the customs, I pay the customs at the doorstep, and everything is fine. I get the parts like in 1 day. But that was on Monday. They called me again. I sent them the information they needed, that it's more than 1 layer. Then on Tuesday nothing happened. And on Wednesday I got the charging information. No, wait, yeah. That I need to pay it. I paid up, nothing happened whole day. That was like 6 in the morning. 6 in the morning I paid it. Here, payment receive. And nothing happened. This is DHL Express, by the way. Express. 1 week, nothing. Oh yeah. Yeah, that's I hate customs. I hate not customs, but specifically the custom handling of DHL. It's horrible. I don't know why they care. Why do they care if the PCB has 1 or more layers? Just because they need a specific number. They bill me? No. Who do they bill? For the Atlas? What? M.1 project. What? Drugs are hidden in the layers. No, it's strange. There's like I think there is the reason is they want a very specific number for the customs, and they're like boards, PCBs. Oh yeah. So there is like a specific number for 1 layered boards. Why they don't just yeah, so and today I was asked by DHL how happy I am with their services. I said 0 out of 10. And then there was the question. How on the scale between 0 and 10. How would you would you recommend another person our services? Was no, I wouldn't recommend. I specifically recommend to not use DHL Express to ship anything from China or everywhere because it's not arriving. It's not express. If you ship it, I was joking, like a guy on a bicycle from China would already deliver it, compared to DHL Express. Hey, Povo. Here in Brazil, the courier services are fast, but you pay a lot. You get taxed 92% over the product shipping cost, courier fees. Yeah, it's the same with WCH paid premium. The content are worth like over $200, and I paid customs 70 on top of that, and probably DHL Express cost them another 70. So it's comparable with the fees and everything and the taxes. I think I don't know if the VAT was deducted already, because that's, of course, that's like commercial, not private, and that's why it takes a little bit longer. But it's so annoying. Anyways, rant over, rant done. Don't use DHL Express. That's the same reason why I'm not using DHL Express with LCSC. Only if everything is cleared. No, yeah, no tariffs for me, I believe. We can check the documents, but I don't want to wait, I will check. Yeah, no, I don't want to dox myself, but I will check if I got the contents. Yeah, there's some documentation. I don't know. I don't want to. JC PCB, let them clear the customs. We can check. I show you. So the assembly, unfortunately, is a little bit different. You can't use the Euro packet, but I was always use the Euro packet for PCBs. That works perfectly fine. JLC, let me check. So you need to use, it's difficult. I want to show you stuff, but with the order history, order, no, that's cancelled. Euro packet. Yeah, DDP is what you want. So they use DHL Express DDP, but this is like for the assembled things. But you pay everything in advance. All the taxes, everything is paid in advance, and it doesn't need to go like through German taxes. If you can skip Leipzig, then you run. And Europacket is like that's shipped, I think, to Netherlands or yeah, DDP. So maybe that's also on WCH to clear the duties. Anyways, I wanted to show the dev boards and a new chip today, but unfortunately we can't do this. I received something else. So the free shipping from AliExpress, by the way, was faster. Also ordered last week. I ordered more of the RISC-Vs for the cluster stuff, because I don't think I have enough. I think these are another 50. Another 50 of the small ones, and here we go. I found a supplier. It's really expensive. Yeah, if you use the choice option on AliExpress with free shipping from 10 euros upwards, No, it's not Charlieplexed. It's actually just a stupid matrix. Because we have enough pins. We didn't even use all the pins. I will show you. We had... there was even... I was even able to use something. Yeah. Yeah, that's... They use... They don't use DHL. I think... Sometimes it comes with DHL, but I think this was... Yeah, they combined it, my two shipments in one packet. And they use, I think, they use Hermes here. So, what is the other chip? Not the MCU, it's the CH382. That's the interface chip. And yeah, we're only using the one serial and nothing else. Not the parallel port, not the second serial. And as you can see here, we have plenty of pins left here on the... Plenty of pins on the main MCU that are not even used. So no need to use Charlieplexing. And I was able... I'm really proud. I was able to find, since we have 12 lines, to find a register PC 0 to 11. Why don't you use MCU with... Oh, do you have one? Give me. I will take an MCU with PCI Express. No. I don't know if there are any MCUs with PCI Express, because that's like, they need to run really fast internally. Does the C3 have? Oh, what do you mean for the pixels? Yeah, if I'm on WCH, then I will use all the components from them. But I could use the C3. I think it needs external components, and this one doesn't. So we don't even need a crystal. That's one of the... Is this... I wanted a solution that's really really easy, because we just need some caps, nothing more. C3. Yeah, it has a crystal. Oh, SD. Oh, okay. I'm open to any suggestion here. We can check that out. Okay, so Docker guy, I am. Hello, by the way, I missed you. Yes, I am from Germany, but okay, so we have the G4 series. Let's take G4. Moin zurück. 12-bit 4 mega sample stacks. Okay. Comparators. Yeah, and they're fast. You can make 4 mega samples. You can make a simple oscilloscope. Yeah. But that's only CAN boss. So it's probably we need. Where do we have PCI Express? Oh, not natively. Yeah. (24-bit ADC). Let's check Mauser if we have like other interface chip. Oh, okay. Single lane, and that's good enough. ARM Cortex, PCI Express, and LVDS. Nice. That's HDMI. I'm wondering if we could make an graphics card with that. Stupidly expensive. We can find out. We can get some samples. Oh, what? That was long. 25. $22 pounds. What? No. 3D GPU. Okay. There is what? There is a 3D GPU. I believe this stuff is. Yeah, there is a GPU on that, peeps. There's even video decoding. Oh wow. For recruiting. Yeah, it's FPGA. Where's the number of pins? BGA. Yikes. Do not want. LVDS. So what do we need? We would need that one at least. 3, 5, 3. Where is better? Is this better? Okay, let's check that one. The price for this. Oh no, wait. Shopping. Shopping. RS Online. Oh no. Ah, okay, forget it. Is that the dev board? No. Producta. Yeah, anyways. Where's the price? Give me the price. The Pogo pins discontinued. What? Oh no. Wait. Ah, no, Mauser. Here. Yeah, 13 euros, 11 euros. That's all BGA, huh? Microcontrollers, MCU. Let's see what we want. Maybe there is a... There is no filter for PCI Express interface. Nope. Screwed it. Okay. Food. Yeah, I need food. Okay, I will get something to drink at least. I'll be back in a second. Good news, people. Good news. I found chocolate resin. Nice. Oh, I love that snack. Oh, no! Oh no, I ripped the bag too open too wide. Now I need to eat it completely. Unfortunately. One. I think it was a hair. FPGA, yeah. I bet going FPGA would work. They make them rip that way, so you will eat everything and then buy new batch. Okay, so the only thing that arrived today micro scratches. They put so this is the listing I got for the M key. Very rare. You can get only a reel of 200 or something. Scissors. So we can actually design. Where did I put them? Now they are gone. Oh, here. So I paid €1 per piece. Roundabout, because no wait, that's 5 pieces for 10, €2 per piece. That's horrible price. Usually they cost 70 cents. But I wanted to have enough so we can populate the first cluster. So this is the plan. Maybe I will turn on the camera. Let me use the other camera. So how did you people enjoy the HDR content that I released on on Saturday, no, Friday. Yeah, probably there. You need to look for new pogo pins. I will link them. I can check if I can find an assortment. My dream would be besides this cluster thing. I will give you a beautiful camera view now. Wait. Yeah. Here we go. Is it? Maybe a little bit more. Oh, what? You didn't watch it yet? Yeah, it's fake. It's fake HDR half the way. Because mixed content. The parts, you can recognize which parts were recorded in 10-bit HDR and which parts were recorded in 8 bits and then tone mapped. And the tone mapping is terrible. Ah. So mixing 10-bit and 8-bit content is so terrible. I needed like hours to fix everything. Here, by the way, not here. No, I didn't. I have an HDR, a bank HDR display, but the handling of HDR under Windows is so awkward. You need to start the main window on the HDR screen if you have multiple screens, otherwise it won't work. And then you need different settings, and I tried many settings with Carl, my cutter, to find the optimal settings for mapping HLG, rec to whatever. And then I needed to use a filter node on each transparent aluminum now. This is the heatsink for my SSD that I that I found in the box later, and now the SSD is underneath my overheating underneath of my cooler. And I don't want to take off the cooler again. I don't have a job. This is my job. Streaming for you here. I think this is 10. This is more than. Is this? Yeah, this is the 10 centimeter one. Wait, here. This way around. Oh no, that's even longer. Oh, interesting. So I'm making this length here, but we can use it as a reference to test our connectors. Because I don't know. Oh, I really don't want to bend a pin. Look at the pin pitch. Do you want a ruler next to it? So Can you look at this? This is 1 millimeters and focus. Yeah, 1 millimeter ruler, and this is the connector. This is the M key. Yeah, that's 0.5 millimeter pin pitch. And what I wanted to know, yeah, this will fit. I think these are like exactly the same ones. Exactly the same ones that you can get off LCSC, because there are no specifications whatsoever here. Oh wait, actually there is this complete specification. Oh no, it's part, it's clipped. I don't want to drag. What? It's clipped. I mean, we get most of the documentation. YouTube doesn't pay for live streams, but I get paid from the video ads, Patreon, some PayPal donations, sponsorships. So at the end of the last video there is a brilliant ad and affiliate. Oh, you mean because I zoomed in? Yeah, I have it on LCSC. I will show you. Where is it? Come on. Oh no, it's gone. Yeah, it's the same. And it's the same on Mauser or DigiKey. DigiKey M.2 Hector vertical. Vertical is the keyword that you need. Ampero, no. That Ampero, that's not the one. Yeah, I know. I just don't want to dox myself, so I will check first and then. Okay, let me check here. Product, no. It's edge port connectors, because there is like, I don't know what's the name, Edemtech. Yeah, that's the. Huh. Okay. So Edemtech is basically re-importing those from China. We have surface mount. Think it might be that. No. Here we go. Oh, but that's the different key. Ay. Yeah. Thank you, M.2, for nothing. Different key.
Yeah, I could just use this key. Because we are not bound to any, and this is unit price is 87. So the question is, do we want to keep using the M key or just another key? Or all keys? Yeah, but then I will have no pins whatsoever. I need all the pins. Because I want to talk about or discuss with you the way I will arrange the matrix so we are able to program it or power individual MCUs on the extension board. Oh man, where is this? Oh no. M key. Yeah, but M key is really hard to get. Where's the stupid? Help find me. SAS M.2, there it is. Okay, and now we need vertical welding. 20 remaining, okay. What? There is E and M key. 2 remaining. Yeah. That's the ones. So here we go. Both, this is M key, this is E key. E key is available, only 10 pieces, and M key, that's also the information I got from JLC PCB. I could try to order one, but they JLC notified me I need to order 650, a full reel. Hey Rohan. So actually, what will it cost? I don't, 500 bucks plus customs. So that's why I paid 2 euros per piece on AliExpress for those.
Yeah. Oleg, can you find them for cheaper? Because I paid 2 euros, $2 per piece from AliExpress for this year. Where is it? Huh? Yeah. What? Adam? Okay. Negative pre-assembly. What do you mean print a new board? Free assembly? No. You can only use the parts that are available in the database. JC would pay for the boards or for the connectors if I ask them. That's not the issue. If we have like a product, you can imagine there will be 8 pieces on one board. So we can make like 40 boards. No, 40 times. No, 160 boards, and then if we make a product, so a reel will be quickly spent. Group gets, yeah, but I like the connector. So people were asking why. Let me open up Paint. Today, oh yeah, by the way, I faked a new cover here. Yeah. I tried a new cover. Looks genuine, huh? Let me. Oh. Let me show how it actually looks. Yeah. If everything is brightly lit with this weak laser, I have a laser that's stronger, but I don't want to kill my eyes. You wouldn't see when I take a picture. So I took a second picture and then cropped it and just and it's even bigger, stretched. It's similar. It's a weak one. It was like in this maker kit, so it's meant to be used by kids. I think it's 1 milliwatt. It's weaker than a laser pointer that I have on this mini keyboard, this mini Wi-Fi keyboard, or what it is, Bluetooth keyboard. So I could use a stronger laser, certainly, or the UV laser for permanence. It's one of the new covers that I'm trying. I could show you side tracking again. Oh no. Hey Udini, thanks for the follow. I modded. What? What did you do? Ah. Yeah. What's going on? I want to switch the account. Doesn't work. I can't. So I wanted to show you the comparison, how it looks like when I can test which cover works the best. Anyways, let's new. Okay, here we go. Where are my tools? They're over here. So why do I need question? Why do I need these connectors? Answer, because the LED matrix project here, this one, is only like we want to test this interface here. And instead of the LEDs, we want to put the connectors here. So this is the M.2. Here, M.2. And we have interface chip, MCU, and then we have vertical connectors. The design by hurt my eye. Yeah. Here we go. Let me record that for the video. So we have connectors like that. Like that. And here, these are the vertical connectors. And there, the colors are overwhelming. Okay. I have a designer tablet. I mean, I have like with my, but I don't have an on my PC. Okay. Okay, and there, many MCUs. Beep, 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 beep. So, this is how the RISC cluster will work. Now, we figured out looked like a classroom. Yeah, it will be a class class 256. Okay, so yeah, no, it's not for the LED matrix. Now we can start design. The PCB is already ordered at Eisler. So let's check. Let's check my LED matrix. It's not started yet. I can still make changes if I like to. So it's ordered. It didn't start. So assembly tests. I ordered it with. Wait, no, that's the playground. I can shake my orders. Wait. Orders. Here we go. Queued for manufacturing. Okay, so it's that will dox myself. So I ordered it yesterday. Yeah. It's cute for manufacturing, and I paid premium for Express. Why do you make an LED matrix that gets power from an M.2 PCIe Express board? Yeah, my reason is because I can put this on inside of my mini PC. Okay, this is passively cooled, so I probably... Oh wait, this is the bottom. I might be able to CNC mill... Was this side? Wait, which way around it is? Which way around is it? I don't know which way around it is. Wait. Huh? Oh yeah, that's just mount. CNC an opening so we can look inside. How the LEDs are connected. Oh, I'm using an MCU to drive it. They will be driven with flow current, so no worries there. We don't need like a lot of power. But we can also actually PC. Okay, no, okay, so PCI Express. So we are using CH382 to interface PCI Express to serial. We can do serial and parallel or second serial, whatever we like. But this is our test board with the LED matrix. And this serial is connected to a main ASIC board. What ASIC board though? I'm not using any ASIC. I didn't design an ASIC board for that yet. Oh yeah, so that's not ASICs. That's just a cluster of RISC-V MCUs. But this is also a RISC-V MCU. It's just a big one. So wait. Let me show the 3D view. Yes, I can do an RGB matrix out of that. I should, because there is an AI that can design PCBs for you. There is an AI for that. So, here we go. This is the PCI Express interface chip. It uses one PCI Express lane. And that's connected over serial to this one here, which I just picked it because it has many pins. Flux PCB. What? Probably, yeah. Tracing took me 5 hours maybe. Oh yeah, Flux AI. Should we try it? Ah, okay. Let me use it. Okay. Wait. What data protocol between the PCI Express board and the processor boards? Yeah. We will have an address like an basic bus, I think like 16-bit. I mean 8-bit address and whatever we like. I will show you. Full name. Bitluni is my and bitluni. Oh, come on. Hobbyist, industrial design, other. Oh, come on, KaiCat. Okay. Flux AI, TikTok. Yes, yes. We just need a dense and common connector that we can use. Really, really dumb. Yeah, they probably accelerate it and deactivate some nodes. Huh? Skip. Oh, come on. Huh? I want to try it for free. Okay, thank you for nothing. What? 15 minutes per answer. What hardware are you running it on? Does it run on the CPU or is it supported already on GPU? That's not enough. That's not enough. That's not enough RAM. Ridiculous. I paid $600 just for the RAM stuff. Four. I think it's four in total. Yeah, that's 128. It's megabytes, so you need to divide it by 2124. Speed lost? Why? What? I don't know. This PC is old already, so really, it's wasted money. Ah, right, I didn't know. Oh yeah, yeah, not on mine. Mine is slow already. My i7 is overwhelmed with everything anyways. It's the bottleneck basically, and the hard drive because it's not cooled. I forgot the cooling sink on my SSD. It's overheating all the time.
Requirements. What? 1.5 terabytes? Multi-GPU. 80 gigabytes times 16. Okay, yeah, that's all right. I mean, this is what I have. I can run this one, the 360 with 12 gigs of RAM. I have that. I have that. This is my card. I can run this because I knew my criteria buying a graphics card is it has to have a lot of RAM. Yes, yes, yes. I bought the right card and I got it during the chip shortage for $500 new. I was just lucky. Yeah, we got the same card. Yeah, it's the best card. It's everything you need. Price, low price, good quality, much power, much storage. Yeah. All right. Anyways. So we were talking about Crash Systems. How much RAM does it have? I don't know. I don't know the specs. So because I mean, they were really stingy with the RAM on the bigger cards for some reason. At least it was like what the 380 and 390. Crash Systems is rich, yes. I just literally, thank you for the follow. Only 12 gigs. Yeah, but it was strange because we got like the 360 was with 12 gigs, but there were the TI 380 Ti or something was like only 8. It was really strange the times then. I know there was like a faster card with less RAM for some whatever reasons. .380 came out with 10 gigabytes. Sick. Less than the 1080 Ti. Oh, crazy. Okay, I wanted to Robs. Okay, we have another project. Open Make Matrix Super 2 project. Okay, that was our cluster. But the cluster, yeah, that was our, we used a different connector here. Oh, yeah, someone has the good earning money. No, there. I will never. If this graphics card dies, I'm screwed. I wouldn't be able to edit my videos anymore. Breath of Love. I'm planning to buy 1970 XT tomorrow. I hope stock and pricing is real. On stock, and then it says, oh, unfortunately, you get the message. Unfortunately, it's not there, and we keep your money. It takes only 6 weeks till you get it. Maybe 6 weeks. Or lead time 30 weeks. I hope not. Breath of Love, I wish you the best. Where you buying it?
Oh no. What did I study? Computer science. NVIDIA drivers are always a hassle. Can't ever get my 3 monitors to come up the same after reboot. AMD GPUs fixed finally. Ah, okay. Yeah. It's strange with the screens, but it works with my 4-screen setup. For some reason it works. And I would love to have a project to make own graphics card, graphics card. I'll show you what my dream would be. Since we started to interface PCI Express, next step, so this is like the stretch goal for this year maybe, or next year. So stretch goal PCI Express times 1. So okay, so and this generic VGA default driver then resolution, oops, resolution, let's do it like that, 16 times 16, something like that. Maybe. So variable, so this will be var setting, oops, and we have here neopixel, maybe matrix, wall, generic UIO driver, basic exposed PCI Express and array memory mapped. But how do you, I mean, what do you map there? How do you map it? I mean, it's a serial interface, so on top. Yeah, so I want this, then I want it to appear here as a 16 times 16 pixel. I mean, and it would be like a really small speckle here. in the setting, or here you can move it around, and then you can move your cursor there, and it will appear on the LED matrix. But imagine the meme. I want this meme to happen. Do it all in the driver. Yes. So I will get CH368. Uh, 368. Wait. This is this is 382. Yeah, 368 is on the way. I will receive a dev board plus the CPUs or the chips. So we can do it, but how do you write a graphics driver? I really wanted something that is recognized as a generic VGA on the PCI Express. Not the CH368 virtual Sphero made a virtual GPU. We only need something like a display port. I mean, there is on M.2, there is one M.2 with different display ports, but that's not anywhere on any motherboard. It was never implemented, I believe. But if we can get somehow like the main GPU, it has like to render anyways to an array and then send the data to a display port. So how do we make PCI Express tell, oh, there is a display port. You need many drivers to show your thing as one screen. Yeah, but I want to use something that's already there. That's not like, that's atypical for me because I reinvent the wheel, but I don't want to mess around with drivers. I could, but I don't want to really. Because then you have like to sign the drivers and Windows and then it doesn't work anymore. So I don't want to mess around with drivers. So generic display port PCI Express. Oh, there is one option. Oh, I found a solution, I believe. Okay. PCI Express to USB 3 and then display port on USB. So it will be recognized as a screen. Wait. I forgot about USB. A psychopath, yeah. Works in light mode. Display port on USB doesn't work unless you have a motherboard that can switch the root display port over USB pins. Ah.
Sorry. Oh, really? You know what happened yesterday in KiCad? It crashed when I tried to via a differential pair. KiCad 9. I don't know. Didn't they try it, or was it just my KiCad that crashed? Reproducible. It was just crashing when I tried to set a via while routing. Yeah, try using differential pair routing and then setting a via. But you don't need that. I have, wait a second. I just need to mimic. I'm wondering, how does that work? DisplayPort 2 DP. No, this is 2-port USB 3 PCI Express. Yeah, but that's not DisplayPort. It only is called DP. Wait. Dual profile. D-Log PCI Express. What is it? No. I want it to be detected as an extra screen. Or we use HDMI for this. We just need to be recognized by the grid. Wait, why don't we mimic just... I mean, it would be nice to have an extra card for that. But just plugging in HDMI and then converting it to... Anyways. Oh, I ate almost all the resins. 200 grams. Oh no. SBC? What is SBC? Single board computer software. So this is Windows. And the cluster will just... it will... So the main CPU will be programmed... Where's the main CPU? The main CPU will be programmed over serial. And that one will communicate with each individual MCU to program it, but the initial programming of the MCUs needs to happen separately.
But I want to use a trick for that. So this is the trick that I came up with. New cat. I don't know if that works because we have the little MCUs have 8 times I think is C port PC, 8 times PD, that is like, that screams for being a nice bus. And then, unfortunately, only 2 more pins. That's 2 times PA. So what we said is we need some sort of clock. So one will be CLK and one will be enable. Maybe enable or something. But the problem is the MCU is programmed over D1 here. We have, of course, the power here. So VCC and G and D. So, and this is the SW, the single pin programming. And the issue is I had the problem that worked if we connect all the MCUs to the same bus here. All the MCUs, so there are more. They are also connected. Oops, sorry. To those two and even more. That worked with the first Linky programmers. But they updated the firmware to the Linky, which does more stuff. And now sharing this pin between 2 MCUs, so that doesn't work anymore. So we can't program it. It will fail because they might be in a different state at the end and whatever. And the programming is happening on boot time, like in the first few milliseconds. I think you can set this even in the fuses. That looks horrible. Make it square. Okay. So my idea now was this enable pin. This is just in software enable. So I want to route. Let's imagine. Let me remove that. Crap. Oops. Let's imagine we have our extension card with all the pins, and we have the different MCUs. Let's guess we have like 2 for now. So I would put these here. I would connect them. It will be all connected. All connected here. So all the MCUs will be attached to the same bus here. Now, if we want to reprogram the MCU, we can turn on each of those individually. And what I was thinking is, how about we using, let's say, this is a matrix configuration, and we have V0, oops, V0, V1, G0, G1. And to save pins, we have now V0, V1, G0, G1, like that. And we can just power up an individual MCU here. Or we can power all of those up. JTAG. So if we connect, so this is, since these are really low power, we can just use shift registers for that. Because this is something that we don't need to do fast. We will just do it once. Let me pick a different color here, like that. Let's imagine we want to power this one here. We will power V1 and G0. And only this one will power up. We can also power up these two. We cannot do like only 3 of those, but yeah. There is one issue though. You need to write an user mode driver and a kernel mode driver. Your kernel mode driver will translate the pixels to your custom thing. These are per device, depends on what you need to do. You can generic stuff, more info. Here is the short interruption. Display driver model. At this point, we will just use USB. But USB with display mode, maybe we can use the Tang Nano somehow to be recognized as display driver. Like an external display port or whatever. Anyways, so this is my idea to have that. And we have like, now we will have basically homeless. I don't know, basically homeless. Let me check. 2 million followers. That man will not listen to me. He will ignore my messages. Okay, That's the clickbait I like. A PC with a nose. First flying. Oh wow. Yeah, some PC mods. 43. Yeah, do it. I will follow him, and then we will see.
All right. So there is one issue though. What if I saw it happening already, that I think it was an 80 mega, 80 tiny or whatever, an MCU will light up because it was powered by the GPIO pin. So somehow ground or whatever it was.
I mean, they should be floating, but what do they do in a powered down state?
So the issue could be now that communicating over D1 here might cause this power to power those up again somehow and doing odd stuff. RPFP matrix. Okay, so I'm worried about this fact. But what we need now is, I don't know. They're just there. We can communicate with them. We can run Luniasm on them. Luniasm, if you don't know, you missed that one. We developed a stack-based assembler
That then can be emulated on any.
that can run this bytecode on any MCU. Powering down in dangerous, going into some sort of low power mode is fine. Think input protection diodes. What do you mean, Terran? Powering down in dangerous. Oh, powering down is dangerous. Why is it dangerous? I mean, I would just turn that one on and be good. If V1 which input protection diodes the built in, or should I on the MCU side? But they're like they only trigger if the power is too high. In it? Yeah. I mean, if you have a too high voltage, because that's like Zener diodes. Aren't they like Zener diodes? Too high or too low? Yeah, so basically what we could do is we could just keep the signal okay. Now let's think what happens. Okay. This is VCC shotkeys. No. Shotkeys are with S and this is Z. Like this. That's Zeners. I think these are Zeners. Not shotkeys. Swastikis. New form of diode. Demonetized. Okay, what is this? This is what? D1. Here we go. Okay, so what if this isn't connected? It doesn't do anything. If there's something coming in, it doesn't do anything. I don't think we need to worry. Otherwise, we can just for programming we can just use maybe a lower voltage, a voltage that's with a voltage divider in between here for the programming interface. We will do a voltage divider with BAM. So this is programming pin, programming, this is D1, and this is ground. Here we go. Divide this to be like 2 volts, and we would be fine. So this would be a fix if something doesn't work. All right, so let's calculate the pins. We have a limited count of pins on our connector, and that's actually 67, I believe. 67 functional pins. We can find out looking at those here. Oh, 75. Okay, I was wrong. So wrong. Oh God. Okay. Let's fix it in post here. Okay, so 75 then. Let's take a new color. Ay caramba. Oh yeah. 75 pins. We have 16 pins bus. Then we have n times en, enable, and 1 times clock, CLK. Then and square root 2 square root of n times, oh wait, times GND times VCC. So what is the highest number that we can fit? A quadratic number that we can fit, more or less. We can use a different. Oh wait, or we do a function here. Okay, so let's calculate x times y, and then n equals x times y. For this exact reason? Oh, interesting. I didn't know. I just thought I invented it. All right, now let's calculate. I will use sheets for that. No. 5. Okay, so let's try and do this. This is 16. Some parameters. It's over. Okay. Yeah, but 64, 32. Okay, we can calculate 32. But 32 is like 5 plus 5 times 4 plus 32 plus another 16 plus 1. Yeah, 58. There will be no way of doing anything. We can do maybe 32, maybe one more row. No, that would be 4 more, 36. That would add 4. It's yeah. But let's not do this. No. Let's not do it. No. Let's not do it. Better 32, yeah. 34 would, 36 would work, but 30, I also thought of 32. And then we have some extra pins. Maybe we put the shift registers. Wait, what happens if we put the shift registers on the PCB?
So we don't need them on the main board. But the power up sequence will be very difficult. You need to shift in to turn them on. Yeah, I mean, you need to do it anyways. So, yeah, but there is not, it will never be more than 16. No, it will be never more than, there will never be 64 MCUs on that. So let's keep the shift registers on the main board because then we can share. And let's aim for 32 MCUs on one PCB. Who will place that? That will be the max. We don't need to populate. We can show. Oh, we can. We can power them. You're right. Why shift registers? We can power it. Just like just like this matrix. Wait. This is we can power 25 milliamps per pin. What was the specs again? This is already our solution. For the power pins. No. No. Wait. So how many CPUs do you want to have? Plus we need like two 16. Nah. No, that won't work. We need to address, we have a lot of pins, so if we want like 8 boards, 256 MCUs in total, what do we do with this extra pin, this enable pin? Is this some kind of address? We need a demultiplexer. LED wall on PCI Express. Yeah, it is possible to swap them by addressable. I'm now thinking. No, I'm stuck already with. On the nodes, ICs, these are LEDs. Oh no, ICs, you mean CH32V003. And they are. Yes, that's the one. And I think it needs only like 1 or 2 milliamps or whatever. It's not
like, where's my data sheet? I wanted to pick up the data sheet, so let's go. By the way, when my PCI Express stuff arrives, I will stream again. Maybe it will arrive this week on Friday. So I will stream again. I will only stream for another 50 minutes today, and then because I'm already tired. Yeah, that's the main CPU is the 208, and the small ones. Where is it? Damn it. Risk V. No. Yes. Wait. No. The LEDs are just for my test now, to see like if our interface works, if we can program the MCU. It's just an intermediate step. Risk V. Datasheet. Okay. The issue is, if we need to run 256, we can't use the GPIOs as a power source, because yeah. Characteristics. Runs on the high-speed internal. Okay. Oh, yeah. Nope. Nope. All peripherals enabled. So I would say if we disable like all the peripherals except for the GPIOs, there will be 5 milliamps, and there is no LED connected. Yes, I would do that. I think either on the board or on the main board, because then on the main board we can share a few shift registers and it looks way cleaner. And you can always plug it in with the pins connected. That's the cool part. Okay, so cool part. I show you the cool part. Okay, here we go. Where is it? So the idea is we need the shift registers only for programming. Imagine that we can also like software program from the bus, so we can send it right this section of the flash and so on. These are power pins. We don't need like to power them individually. We can have like on our board that doesn't program it. We can just do the following. We'll just do all the grounds are just connected to one big pad and all the VCCs, so they are always powered and we don't need to do anything about the switching. We just need a programming board where we plug them in and be good. Program it once, then we have like the original firmware. So I will make one board that is capable of switching it and one board that's not switching at all. It's just all connected, all grounds connected, all
So how about that? Smart. Components saved. So if this is a product, I would I would just program it in the factory with a custom firmware, and then from that point on it will be programmed over bus. We don't need to take care of anything anymore. Oh yeah, that's interesting. What will we do with the GPIOs? Because we have like 256 GPIOs at the end. What do we do with that? I mean, the bus will be connected to the main MCU. That's all right. But what do we do with A1? Like, okay, this is enable. We don't have 256 enables. Like we have a ton of enables here. We can use them as enable, but we can use them as something else. As a GPIO, an analog GPIO, whatever. So let's just call them A. We will root them and then see what happens. A ton of we can add another LED array or something, or a ribbon cable with 16,000 pixel LED matrix. Actually, that could work, but then ESP and boot through UART. Oh, yeah, on these 003, you can program them over serial, but they need a custom bootloader for that. So, or like a firmware bootloader. So the 003 can't do that, but the 208 can do this. So 208 will be able to be programmed like that, Fenoir, but that's how we will program it through here. This is for our boot selection. Oh no, that's all right. I said it in the beginning, but this is the main controlling MCU at the end, and it has a boot sequence, but I think boot 1 needs to be low, or no, ignore. Boot 0 needs to be high, I believe, and then you need to reset, soft reset, and then it will start, and you can program them over serial. So this is how I will program this one, and this one will control the matrix of MCUs, not the LEDs. The LEDs is just an intermediate project to test that. And I hope we will receive our dev boards this week still. DHL didn't do anything. Where's my DHL? Okay, anyways.
I will keep you informed, or you ring the bell to be notified if there is a stream on Friday. If I receive my boards, I will stream again on Friday, okay? The MCUs are the QFN, this package, wait, here. I show you. Not von Duken, wait, here. Ah! Yeah, we can do actually an analog camera with that. 128 by 128. That's actually really cool. Here we go. That's the package. QFN 32, I believe it is. Is it 32 or 24? No, 32. It needs to be. No, 24. Check. We have the data sheet open. Here we go. 5 milliamps. Here. QFN 20, sorry. That's why it's only 2 A pins and whole as real. No, I don't have the whole as real. Wait, maybe I have a JLC. Wait, let me check how many I have in stock on JLC PCB. Let me sign in. Parts manager. Oh yeah, I tried to order 12. They said, no, not possible. You need to order the whole reel. So I tried that. Here we go. 600. And they cost like 600, cost me 73, and then I got like refund because it was cheaper to get them. I paid actually 10 cents each. And I still have them, I think. Wait. How many do I have? Because I ordered already. Yeah, so basically I have a few on stock there, but I can also, if I get my Isla boards, I can populate them here by hand. At least the first arrays. Hey, Michael. All right. This cutesy little part. Now I know they're not getting rich. They paid more than I gave them money. Because they sent me like for $200 the dev kits, and I bought maybe in total all the CH parts that I bought maybe $200. Okay, I promoted the MCU, so. Oh no, wait. WCH, I used their serial ports for my products already. Like the serial chip, the USB serial. Yeah, they're everywhere. They're getting rich because they basically replaced TDI. No, what's not TDI? What's no. What's this old school USB? Yeah.
what's the old school MTD? No, what was the stupid serial chip where they FTDI? Yes, FTDI, and where they changed the driver to where they decided to screw up everyone who didn't know. Yeah, who didn't know that they're not having the genuine chips. Kill switch. Bricking, yeah. Third party chips. Never forget. Everyone. But they got rich anyways. They were quite expensive, the FTDI, the originals. I remember it was like always the Arduino Nanos or Megas with original FTDI. Whoa, no extra driver because it was included in the Windows update. And then WCH got their driver finally in, and that was a game changer. Oh, Max Linear XR21. What complementary? I think one cap, but I think we can run it without the cap. You like them, Yombo? Why? Is there something special? I mean, they're quite stable and compatible.
Fenwal, let me check that one. Oh yeah, it's a tiny chip. Nice. Yeah, I've got also some FTDI dongles. That's cutesy. That chip, Max Linear, is really cute. Here, Pips. Nice little serial chip. Oh, nice, Adam. Yeah, USB program on the ESP32C6. No hardware required. But you still need the crystal, do you? This is something that I like about WCH. They have like the internal PLL. Since they don't need a crystal, it's just a one chip solution. Oh. No external flash, no external crystal, nothing. You just take it and have something unstable. Yep, the ESP32 bootloader is rock solid. Okay. Okay, rambling here. Let's start our design. We can hard break 5 milliamps. Oh, sorry, I'm sorry. Shift registers. We need sink and source. Which did I use for my flip dot matrix? Oh, just for the power. I need to power sequence to program the individual ICs. Here. Power sequence, like the power matrix. I need that for the programmer board. And I have some shift registers here for this is basically also powering everything. Hey Rickard! What was with my voice? My voice cracked. Here. Okay, I used 595 SN74HC595. Yes, I can use MOSFETs and... Hey, Elliot. Nothing going on here. We just trying to discover how to make a powering sequence with different ground and source pins to not source. Source is ground. VCC current source. What is the abbreviation for? It's late to ask, I know. University. Five 595s. Okay, so these are... It's not your favorite class. Okay, so wait. Q. Oh, because I don't want the programmer board. If I have 32 MCUs on there, I want the programming sequence to be, let's say, I want it to be automatic. So it will, even if I only want to program one board, I want, like over serial, to be able to tell the programmer board to switch to the next one and then continue pushing the firmware, switch to the next one. So it will be automatic. Like, I think it's important to have everything in mind and like keep it simple for myself right now. If I can, I need to program them anyways. I could do it with like jumper wires, but I really don't want to. 32 times. And then I screw up and whatever. I could do it on a breadboard. N and P channel. Yeah, because oh, you mean because, yeah, You can go with 5 P. No, wait, 5 times. What did we do? Yeah, 6. I would arrange them differently on the main board because we have 5 connectors. We could do that actually with P channel and N channel MOSFETs. Is there any reason to not do it like that? No. Yeah, that's for one board. If I make the programmer for 256 MCUs, that's 8 by 8. So 16 more pins. Now I have to think. If I want to make a simplified board that runs all 256, so we have 8 expansion cards, 32 chips. If I want like an extra to only program them, but then I need to reprogram them more often or whatever. I don't know. Is it smart to try to tackle everything? I have like one master board that works as a programmer as well, has the shift registers on the back, so I'll be able always to reprogram them manually. I don't know. But that could work. The only thing that I know that might be an issue is 32 seconds, maybe a minute for one board. I was watching the Megaplex video, got super curious about how you programmed such a big child. The Megaplex, I think this is quite simple. It's just like this matrix, but you don't have the center diagonal, and then you connect them like this. I think rows and columns are connected. There is the Wikipedia is quite good on that. So in the Wikipedia there is even here. There is the number that you can do, and where is... Oh yeah, this is how it's shifted. Is there any good code? And if you play around with the Charlieplex, you will just discover that it's like a simple matrix, but it's cut diagonally and then shifted by one. So you have like the first row is all LEDs except for the last one, and the next time you have like all -2, and then you skip one, and that's shifted like that. So it's just shorter and shorter, and you skip one LED, and then of course you need to do like the tri-state stuff. But this is like, if you manage to turn on 1 or 2 and Charlieplex them, you will quickly figure that out. I don't know if there is a good starting point somewhere. I'm not sure if... I might have published mine, but it's highly optimized, so it doesn't look good. Tri-state. You can do it with Arduino digital read and digital write. I mean, pin mode output or input. Input is basically tri-state, like floating, and then you do pin mode output, and then 1 or 0. So that are the 3 states: floating, 1 and 0. Yeah, that's quite easy with Arduino. A POV volumetric display. Oh wow, yeah. Oh, that will be hard. You need to switch really fast. That will be hard with Charlie Plexing. Hello, Linorant. Thank you for the follow. You need to switch really fast for volumetric. Do you want to like to rotate a whole matrix? All right. So, okay, let me check something again. Yeah. I would use addressable LEDs because they have like a stage. They are always lit. So like the really small pixels, you can get them like 1 millimeter across, like the addressable LEDs, and you can send it quite fast. I think they might be faster than the 800 kilohertz ones, and you can use multiple channels if you want it faster. So sending multiple rows with I2S upper, yeah. Yeah, you can just parallelize the addressable ones, and the addressable are always lit. So you won't have like the scanning like your POV would look like a rotating line or something. Yeah, at 60 hertz at that rate, yeah. Right, Appa. You need. Oh, yeah. That will be interesting. A challenging project. But you might be able to run it faster. Yeah. Kilohertz. Okay. Storage. Upper SPI LEDs, yeah. Yeah, just parallelize it. Multiple lines. So all right, so can I run 256 individual? What did we say? 4, 5, 9 pins times 8. Yeah. Yeah, I want the shift registers. Because or drivers. Shift registers will be easier. I can just attach them to imagine I can use the same PCB design for the programmer and non-programmer and just attach the powering if I need it. I can either attach it to a few pins here, or I can bridge and cut maybe a trace that's connecting all the grounds, or yeah. So what I would do is on the bottom of the PCB, I would do something that I can bridge, not bridge, cut the connection between the grounds and the VCCs, and place the shift registers, and I can control them over this MCU. Otherwise, they would be always on. So I can have the same PCB design with which acts like a 0-day programmer. Day 0, initial programming or debricking, how I would call it. And after that, the bootloader should be able to handle everything, or like the firmware itself. So if I can make the bus be read and written in the bootloader section, then I can just use the program section to do anything. I just need a stable code for the bus, and that's all. So that's the idea. Oh no, we have 12 minutes left. Was already just talking again. Yes, CH has IDs. If you watch my mega cluster or super cluster video, you will I talk about that as well. Wait, this is not, that's bitluni live. Mega cluster videos. Here. Nope. Here. So this was like with the bigger MCUs, and each had like one LED. And they have, I think there is look at the wiring. That was my old one. Wait. I think in the supercluster video. Where is the old one? This was the one. Supercluster. Beautiful chaos, yeah. Yeah, that was the struggle of programming it. Yeah, yes, it programmed, nice. Yeah, that's unique ID, and then there's like, so that's explained there. Oh no, the benefit's better than me. Well, was the only thing I could come up with. There's, now that I see that, it might be good to use an open collector bus. What? ESP IDF, I got strange voltage levels. What? I missed the whole discussion. All right. Yeah, so let me check for the shift registers. Where was my shift register? Already. Okay, that's the... I don't get... Is this like milliamps per pin? V out, I, okay, clamp current. $70 milliamps is max. So we have 8 pins. Oh, it's not enough. We might actually need MOSFETs. High side driver, low side driver, sink and source. Let me check. HC 595HC. I know UTC. Wait. Hey, DHC. Do you have such a long commute, or were you on visit somewhere? Ah. What is this chip? Oh, new glasses. Now you're enjoying driving car without bumping into stuff. What is this? UTC 627. Serious gate drivers. One at a time, but I want also run them all at once. With the same board. I have very high demands. Okay. DMOS transistor. Output current. Yeah, I think this is what I want to see. A duty. Hallo, mein Bruder. Hey, Isolation Games. LED driver pins. Okay, so I used those shift drivers for the flip dot display. So if we can run a mechanical drivers, then we can also. These are, I think, the low side. Yes. Wait, output. Yeah, this is the low side. Oh, that's parallel. Oh, that's yeah, 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 yeah. I don't know actually, but it worked. Or they are also driven at 24 volts, so it's a little bit less current. Okay, this is just the driver stage. I have already for the other boards but this is parallel, not serial. DMOS, source type DMOS. Will you have 6-channel shift for VCC and 6-channel? Not because I want to have more than one boards. I need at least 16. But the issue is then I can't use 32. I will need what is it? 32. That's 4 times 8. 4. Oh no. Wait a second. How is this? Now I'm confused. Let's add a new layer. Okay. Maybe it's not that bad, so we think everything through. But we have 8 times one board. We have 5. And we have 4 for each. No, we are working. The LED matrix is. We are waiting for everything. We are designing the boards, which LED matrix will be assembled next Wednesday. For sure. And you're right. Uh, 30, 16. You are right. 6 times 6. That's okay. Do we have even enough pins then? $36. Now we need to scan like that. No, we need 6 each. That's a lot. Is there a way to distribute them so they can share?
So if we have all, if we do it like that, we do 8 times 4. Do we have enough pins for 8 times 4 in our calculator? So if we have like, so 32 plus 16 plus 1 plus 8 plus 4. Did I miss something? Did I forget anything? Let's do the math. Yeah. No. That's all right. 32. 16 is the bus. 32 enables. 1 clock. 8 grounds, 4 VCC. So because that might be better to have, let's do it like that. Oh no, shit. So we will do it like that. This is excellent. This is way better. Well thought through, peeps. Well thought through. Here, 8, 4. That's the constellation that we take. 8, 4. And then we have on the main board all these 8. This is one driver. They're all connected. And then we have this 4 times 8 equals, so we have 1 more 8 source and 4 times 8 sink. Okay, so we have high side and low side drives, 5 chips, because these are not shared and these are shared. This way we can address all these are all individuals. Here are these ones. These are all individual ones. Choo, 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 choo. Okay, let me record that for. So all that are individual pins that are like 2 are connected to one IC here. One high side. I don't know if we need like the driver stage, probably. So we are fine. This will be this distribution. So the new pinout is 8 times ground Oh, I have an idea. Oh, that's good. 4 times VCC. We have spare pins. Then we have 1 CLK. Clock. Then we have, oops. We have 32 times an analog pin, and we have 16 times bus, and this will be oh, sorry, you're right. Oh no! there's something on the other side. This is painful to watch, huh? Wait. Here. 32. This stream is over since a few minutes. Okay, let's calculate how many pins we have spare. Wait. 8 plus 4 plus... Ah, no! 8 plus 4... Hey, clear it! Where do I clear? I want to clear everything. It's still... Huh? How do I clear it? Zero. Oh, here? Okay. Okay. 8 plus... Oh no, not divided. Plus 4. This is painful to watch. Plus... Not 16 for the bus. Plus 1 for the clock. Plus 32 for the analogs. Plus... That's 61. Then we have still 14 pins left. 14 extra pins. You know what? I will do the following. Oh no, wait, I won't do. 6. Oh, the key. Oh no. Yes, numeric keypad. Oh wait, did we? How many do we lose to the key? Sonic, I totally forgot. 75 is the total. If we have like the key. Really? Okay. Oh. So we have 6 pins left. I was just wondering if we can do another set of ground, but 6 is not enough. Ground and VCCs, so we have an alternative to power it up. But I guess let's forget about it. Let's not overthink anything. CH bus. It's always fun. Yeah, especially I'm happy with that here. So I will figure out which chips we need. And I think per blade. Maybe 22-bit was. Okay, peeps. I hope DHL will finally deliver my dev kits. So I will be streaming on Friday if they arrive. If they not arrive, I will be assembling the LED matrix, this one here. I will assemble this on next Wednesday. Otherwise, let me show it again. Otherwise, we will stream on Friday and test the PCI Express stuff, because we get some dev kits. I'm really looking forward to it, and I want to test it with you. Oh no, I'm recording everything. Oh no. Okay, here we go. Yeah, this will be assembled next Wednesday. So thank you everyone for watching. I think this is enough rambling for today. We have a good solution here with, no, not this one, with our nice CAD software. We advanced from MS Paint to Paint. Oh wait, I have still the old ones. Look at that. This is still the C64 cartridge version, which, as you remember, we will be using one pin as address. The enable pin will be used as an address, enable pin as an extra address pin. So this is also figured out. Let's see. What did we figure out there? Because that will be, oh yeah, we will be using it differently. So it will be 4 pins for read, write, whatever. No, what is this? Address? I don't know. Oh yeah, that might be a different, I don't know. I think the address pins 16. I just want to make sure that it will also work for our C64 cluster. So that's the idea. That's why we need the 32 pins for as enable or analog pin or whatever, because that is basically the address bit that we need to demultiplex. All right. Thank you for joining the stream, and I'll see you next week. Bye bye.